I'm going to talk about BlueOS, and in theory, it's related to companion computers and how you're going to integrate it with your vehicle. I also want to talk of other things about ground control station software and what we could do if we run flight controllers direct on Linux over running microcontrollers. In our use case, it's totally fine. I know there are some critical applications, but I believe that's totally doable and possible. So I'm Patrick. I work for Blue Robotics. I'm really active on GitHub, so you may know by Patrick Electric or my avatar on GitHub. We mainly work with submarines and boats, autonomous boats and electric submarines. Some people do work with the boats the submarines to make it totally autonomous. And since it's a complex environment with video and network device, network sensors, the vehicles are usually really complex, and the solutions for it also need to be really broad. Such vehicles, they are not like out of the factory, ready to go for some customers because they want to integrate with different sensors, sonars, and things that are kind of hard because the drivers are sometimes closed source, they are a bit obscure, the software depends on Windows. So there are things that we try to do as much as possible softwareize with the companion computer. So what is BlueOS? First, I talked about the start of the company, or if someone has started doing Raspberry integration on a flight controller, probably started with Companion. I saw Companion at the time, it was something from 2015. And that's how Companion looks for a client. It was not that okay. The original software concept was to just deal with Mavlink streams and video streams from the companion computer and the flight controller to the ground control station. And for that, the user will be able to control the vehicle and at the same time see the video feed. The video can be at the time, any USB camera that supports 824 encoder. And we had this limitation, like you could only use a single camera or a camera with this feature because 824 encoding was what it being used. We have a fixed JStreamer pipeline. We try to make it smart, but kind of a bit hard to do it when you do with like raw JStreamer pipelines. And we use it at the time, Mavi proxy to do all the routing process of the Mavlink. It was created in 2015. It was a monolithic project, it was huge. It was really complex because the backend was also connected to the front end in a way that the changes affect, it was really problematic in a development point of view, and maintaining it was really hard. And it was also designed for a single vehicle, a single application. At the time, the company was just starting, we were creating our first submarine, and that's it, just a development for the product. And you're also not created for dealing with custom builds because besides selling our robots, we also sell other components that people need to integrate with. So if they want to use Companion, need to use Companion, they need to modify Companion itself to add their sensor integration. And to do that, they need to have a Raspberry Pi image, modify the Raspberry Pi image, and send it with the clients. And if we do updates in our Companion software, there are no way for these people to update their software as well. So it was a real problem. And it was deployed as Raspberry image. So every time that you need to update a Raspberry, you need to flash the image. And the update process of the software was through Git pull. So the update was just like fetching the data from GitHub and updating all the software running locally to just do the software update. But we also had a bunch of bugs because of that. So software updates were a problem. Supporting more accessories was kind of not possible without doing code there directly. Development was hard. Performance was a huge problem. Customization is also something that was not doable. And in the end, there is no way for us to continue maintaining the project in a way that we could use it. And we learned much about it. And that's the idea of BlueOS. Our vision for BlueOS is to create an inviting experience for developers to build and monetize their own products and solutions. So when we started work on it, it was not for Blue Robotics only, but for a range of products, a range of like vehicles, and also for third-party companies as well, because we are the people that create the hardware, and we have third-party companies that modify this hardware, create other vehicles based on it, so we need to support that as well. And also, our idea is also to unify access to tools and service, creating a cohesive, welcome user experience for vehicles in general. We started with ROVs because that's our main vehicle. After that, with the soft architecture that we created, we're supporting boats, but our idea is to support aero vehicles and ground vehicles as well. And also simple by default, but powerful when needed. One of our main points of the software is not to be something that the user will be afraid to use it. It should have a welcome experience. People should be happy using the software. It should be just a software that people are glad to use and beautiful. So our idea is that user experience in user interface is truly important as not only the features. And our idea is to be loved as a software platform where people just have to use it, developers or final users. So what is BlueOS? As you can see, this is the image of BlueOS right now. It has like menus, like you can just click to open some applications. You have a sidebar that you can open and select different pieces of software that are running. You have a top bar with widgets to select, and everything runs in the browser. So you don't need to have a direct connection with the display on the vehicle. Everything that I'm talking here is web-based. So BlueOS is embedded in the ecosystem built on Linux. It runs inside a Docker. So if you have a Linux computer right now in your robot, you can just run BlueOS ready to go. If you have some knowledge in Docker, you can just do the correct Docker binds and BlueOS will just run. We have Wi-Fi configuration, Ethernet configuration. We create Wi-Fi hotspots. We also deal with like DHCP server and a bunch of stuff. So it's really nice if you're a developer, you want to do such thing in your vehicle. It's high modular. We create the architecture based on the microservices. All the services that we run and create the functionalities of BlueOS are isolated and it can also run as a standalone applications. The software was created to be easy, reliable. Software updates are reversible, so we have an API that we try to maintain and have control to avoid breaking compatibilities between BlueOS versions. And at the same time, since we use Docker, it's easy for people to do updates. The UI is very web-based, and also built around modern technologies. Mostly everything that we do is done in Vue and TypeScript. The backend is powered by Rust and Python 3.9 in the moment. We are moving to Python 3.11 as well. And as I said, mostly of our core and critical services are done in Rust, and I'm going to put more details on it later. We also support any vehicle that uses Mavlink. By default, the only protocol that supports Mavlink. We do have plans to support other protocols as well, but for now, that's enough for us and to support other like flight controllers as well. And at the moment, we only support the Raspberry Pi right now as an image. So we deploy Raspberry Pi images in OCI. You can take a look on GitHub. Every single version of BlueOS, we also deploy a Raspberry image, and after also that, Docker images as well. And everything is open source. You can take a look on Blue Robotics BlueOS page. We have the entire documentation. The documentation is one of the best. I'm truly proud to say that. We have a really good documentation with BlueOS. And right now, if you talk with anyone that codes with PyMavlink, probably went in our website, in our documentation, because I think we have also the best PyMavlink documentation around. And as you can take a look, it's really active, not a bunch of contributions, but we have contributions. And the idea here is to have more people to collaborate and starting use it. So let's take a look. This is the page that you see of BlueOS when the user opens for the first time. So you can see there is a picture of the vehicle, has the vehicle name, and also has the logo of the company and logo of BlueOS. The interface is also, you can also customize the entire user interface. The colors, icons, the logo, the picture of the vehicle, everything can be configured by the user or by a third-party company that are creating their own vehicles to replace it. So if you don't want your look and feel, but you want to create your own look and feel, you can do it. It's totally possible. Modifications of BlueOS is not necessary. You can just provide the modifications as JSON files, and the interface takes care of everything, and the configuration is done. You can also do it via the front end as well, directly. So as you can see, that's a simple page here, and we can have some icons on the corner there. So we have this yellow icon with the Ethernet cable saying that, oh, you are not connected via Ethernet, you're connected via Wi-Fi. So connection with the vehicle can be deprecated. We have the heartbeat icon pulsing to describe that we have connection to the vehicle, we are receiving heartbeats from the Mavlink. We also have light and dark temps for people that just want to don't want to work with light environment. We also have Ethernet configuration, Wi-Fi, and also a notification system. If something goes wrong, all the user needs to be alerted by something. And if you enable pirate mode, that you can see the other image, we have this happy robot icon. If you click on it in enable pirate mode, you're going to have full power over the interface. You're going to provide everything that is really complex about the robot and can be dangerous by our normal user to mess up. In this, we can check a look on the available services, modifying the settings of the front end directly. You can have file browser, Mavlink endpoints configuration, Mavlink inspector, NMA injection, and also bridge for serial configuration, and also directly terminal access. So the idea to make it simple but powerful when needed relies on that. It's really hard when you try to develop an interface that is friendly for users and empower users that have knowledge and experience to modify the system. So our idea is to use pirate mode to show all the advanced features for the user when he requires. And we have the Autopilot page that you can just do firmware updates and configuration of the Autopilot. You can stop, change, start. We will also support multiple flight controllers running simultaneously on the same Linux computer. So if you have multiple Pixhawks connected, you can change which Pixhawk you want to use. We also have parameters configuration, parameter metadata. We don't have support to PX for parameter metadata yet. We're still working master branch. And we also have the access to all services running on BlueOS. So each service by default on BlueOS provides a web page with a web API. So you can access the API of every single service if you want. So if there is a program that you are creating that needs to modify Wi-Fi configuration, modify Ethernet configuration, or run commands directly on this computer, you can do it via our REST API. We also have no plans to break the API because we want to support people to develop their solutions over BlueOS. And at the same thing, we have access to Mavlink and more stuff that I'm going to talk about it later. And all the documentation for every single service is also available. If you go there, you can take a look on the API documentation page. It runs on the vehicle side, so we have access to all functions in all the configuration that each service provides as well. We voted for a Swagger and Open API description. All services have that, Python and Rust services. So you can, in this example, we have Cable Guy service, or our services have some kind of funny names or nice names. In this case, you can do Ethernet configuration, take a look on the interfaces on the network that are available, change your network interface priority. Sometimes you have a really advanced robot that you need to change between Wi-Fi, Ethernet, and different Ethernet configurations. Maybe you have a 4G connection, satellite connection. So in this case, we try to support everything with in this service as an example. And you can also do firmware updates, software updates in BlueOS. In this case, it's running the latest 1.1.1. Otherwise, update icon would show up. But it says to the user, oh, if turn on pirate mode to view all available BlueOS versions, including previous install stored on board, as well as passing current stable, beta, and development release downloadable from Blue Robotics. You can also, if for that, you just enable pirate mode, and you have access to all available BlueOS versions locally. In this case, there is add beans that I was working on locally. And also the factory BlueOS image. If something goes wrong on BlueOS when running, by default, it does a fallback to the factory version. and that it tries to restore the functionality of the vehicle for the user to not lose communication or control of the vehicle. And also has access to the Docker repository. So if you have your own BlueOS repository with your own BlueOS versions, you can just put your Docker Hub user there, and all your versions will be automatically showing up for you to change. We have also support for the file system. In the file system, you can have access to all files running on the host computer and also the Docker. You can also take a look at the logs and other things. We also have logs support and visualization with UAV log viewer. So if you have a log on the vehicle, you can run directly UAV log viewer on the vehicle site. Don't need to be run online or using a web application on the cloud. We have Mavlink bridge connection and also Mavlink inspection directly on the front end. For Mavlink bridge, we use right now Mavlink Halter. We do support Mavi proxy and also Mavi P2P as alternatives to Mavlink Halter. Each one of them have different trade-offs. That's why we support all three. And it's the decision of the user to choose which Mavlink backend he wants to use for do this the proxy. In this case, we can see there are a bunch of Mavlink endpoints created that runs as UDP server, UDP client, and there are others that the user can create to just split the Mavlink connection to other softwares if necessary. And in the Mavlink inspector, you can take a look on every single Mavlink message running, and you can also have a JSON description of the Mavlink data being updated on real time. We also have network speed and latency test. On a submarine, it's really important that your connection is reliable because you have a live feed of the video directly from the tether. And in this case, you need to run a network test to see if the connection of the vehicle is working fine. And at the same time, we also have internet speed test to see if the vehicle is connected on the network via Wi-Fi and check how reliable it is. We also have NMA injection. We transform NMA packages to Mavlink, and with that inject this Mavlink data directly on the flight controller. The user also has the option for creating serial to UDP bridges. So if you have a Arduino or any serial device connected on the Linux computer, you can create this bridge that allows other services or your software running the Surface computer to access the data. We also have support to different hardwares connected on the vehicle. In this case, have two sonars for ping 1D and ping 360, and we have drivers that detect these services and provide this information for the front end. The software architecture was created for people to just integrate their own sensors as well. We also have support to vehicle information on the hardware. In this case, we have process information. You can take a look on every single process that is running. You can check out the percentage of CPU usage, network configuration, demask from the kernel, and also take a look on which companion computer you are running. The idea is to make it easy for people to take a look and investigate if something goes wrong. The network configuration provides a number of packages in real time that are being communicated. The process list can take a look on the CPU usage if something goes wrong, and you also have advanced features for processing and analyzing it. And the user also have access directly to the terminal of the system. In this case, by default, the terminal runs tmux, and you can just split things around, open different softwares, and mess around. And since it's tmux, you can create multiple sessions, and everything runs, as I said, on the browser. So vehicle terminal access should be easy. We have a bunch of binaries to help developers, I2C, UTIS, BAT, MTR, and everything that a user for debugging and development should care. But by default, we use the Mavlink camera manager to do all the Mavlink bridge from the companion computer to the Surface computer. In this case, we have a fake video stream and a connection with the Raspberry camera, both using RTSP and the other UDP. By default, the camera manager also creates video streams that displays via WebRTC. So if you have a vehicle with a camera and the video feed is being provided, you can also access via WebRTC in a web application. And as example, you can create your own string, personalize it, support different endpoints. We support different, like 4 different encoders in cameras. We also provide 4 different endpoints for camera streams. We also support thermal cameras, and you can also disable Mavlink directly if you want. We also have support to controls of the camera, if it's a video for Linux camera, and we're still working on OnVIF support as well. Slowly. So we also have the vehicle setup page. In this case, we have a submarine, and you can also just run the submarine around. We have a review of the camera, we have data from the sensors. You can also configure each motor individually. Sometimes it's hard to do motor testing configuration, so it's nice if you can highlight them for the user to take a look. And if that the user can understand, okay, oh, this configuration is tagged with this device or this part of the vehicle, and do the configuration directly there, and if necessary, you can also, as I said, do motor tests. And this 3D viewer can also be totally customizable without modifying BlueOS. That's an important point. So via JSON description file, you can just put your own 3D model, and also configuring the highlights of the motors in each component piece with a directly reference. And that's our idea, is to allow third-party other companies to use the software in their own 3D model as well. And we also have a configuration for the vehicle, like a wizard. So in this wizard, the user can set the name of the vehicle, the MDNS name of the vehicle. By default, all the vehicles on the network have MDNS names. Well, what that means is that on the browser, you can just type myvehicle.local or bluerv2.local on the browser, and by default, BlueOS opens. The default name is BlueOS, so when you type blueos.local in the browser, the vehicle, the BlueOS should show up, but you can also modify, add names, change icons, configuring everything necessary for people that have multiple vehicles on the same network environment, and do the configuration on each one. And some languages and frameworks that we use in the decisions that we have about it. We use Rust for critical and performatic services, and also self-contained projects. In this case, it is Mavlink to Rest and Mavlink Camera Manager. We also use Python for exclusive projects, and also for components that are critical, and performance is not that required, and use Fast API for providing all the API and documentation for our Python services. And we also use Vue, Vueify, Vuex for web development, and the entire front end is done with that. And we also use Docker for BlueOS, update extensions, and managing other things in the background. We use Mavlink to Rest. As I said, the service is important because it was the base of everything in BlueOS. BlueOS is a 5 years project in development. Mavlink to Rest was the first component as a proof of concept. It is based on the Rust Mavlink, the Rust library for the Mavlink protocol. And Mavlink to Rest does a bridge between Mavlink and creates a REST API to develop web applications. It creates a serialization of the Mavlink protocol via JSON. It also provides an entire RESTful API via WebSocket, so real-time data of the API, real-time data from Mavlink can access it on the front end, and also provides TypeScript definition for serialized message. So it has its own TypeScript definition for Mavlink, and if that should be safe for you to do your own front-end development, and also develop it in Rust because it needs to be really performatic and nothing can go wrong. We also use the Mavlink Camera Manager. Both of these projects were created for BlueOS, and after that were moved to Mavlink organization. In the Mavlink Camera Manager, as you can see, we support multiple inputs. Right at the moment, USB, CSI, ITCP. We are working on OnVIF and others. We also provide a series of endpoints integration like REST, Mavlink, Video for Linux, SDP, OnVIF, WebRTC. Main outputs as UDP, ITCP, WebRTC, and thumbnails. You can also grab screenshots directly if you want. And also it was designed to have really low latency. We can get around 120 milliseconds of latency, but it depends also on the camera. We support H.264, MJPEG, RAW, and also we do deployments in binary for x86 and ARMv7 at the moment. And as I said, both projects are part of the Mavlink organization, were developed for BlueOS, and we maintain both projects under the Mavlink organization as well. And Something that we usually get asked about on the company is like, how can you integrate your own software, or how you can integrate your own sensor, or how you can make anything. And sometimes when you have a system, it's really hard to think, how can you integrate a specific sensor that is really complex, or just create your Python script and make everything work? So we have these questions for sensors, sonars, actuators, different configurations, different behaviors of the system. People just want to make a system that's totally autonomous. And also ROS, OpenCV, in OpenAPI integration. For a manufacturing, supporting everything is really hard. For any company supporting anything, like it requires a huge number of developers to make everything work. And it's maybe hard. So the idea is that the community can develop their own solutions for people starting integrating their own software. The extensions on BlueOS provide a way to build features and capabilities of the system. So if you have a sonar in a manufacturer, you can just provide the BlueOS extension and everything should be ready to go. So the idea is to support new hardware, add new features, new user interface. You can do an entire configuration of BlueOS interface on extensions. And they are distributed through an app store. We call it BlueOS Bazaar. And everything is one click to install. Our store allows every single application that's available to be installed with a single click. Nothing you need to buy or register, accounts are not required. And everything is done via Docker, so everything should be safe and fast for updates. By default, using Docker, we also isolate extensions from BlueOS itself. And so if you are running an extension, probably nothing should happen with the system. If the extension goes wrong, the extension will be stopped and the system should continue working. And most everything is free, and paid extensions are possible. All the extensions that you have currently are free, but we think in the future to have paid extensions for other third-party companies that want to sell extensions. But at the moment, we have a public store that I'm going to talk more about. So right now we have these extensions available on BlueOS. We have Nortec Nucleus for DVS, we have Node-RED for block diagram programming, raw support, Yacht for Docker management, OpenVS Coder. So if you want to code on your vehicle, you don't need to install all the development tools on your computer. You can do that directly on the vehicle side. So you can sell a vehicle with BlueOS, have all the libraries necessary for development on BlueOS itself, and the user can just install the VS Code extension program there. We also have Jupyter. We also have a bunch of examples for the sensors on Jupyter. We have Sonar View, Cerulean, WebRTC, Zero Tier for remote network access of the vehicle. So sometimes you have a robot running, and in Brazil, and you want to control for United States, you can do it with Zero Tier. It's a really good feature that we have for remote control of the vehicles. We have USB IP for accessing USB devices that are connected on the companion computer, because sometimes you have a sensor that is not doesn't have a driver on Linux. Doesn't only have a driver on Windows. So with USB IP, you can connect this device on the Raspberry, on the companion computer, and you can access directly on the computer that you're running, on your Surface computer, to access the USB device on the vehicle. We also have virtual here for remote USB access as well, and other extensions to talk more about Cockpit later as well. And everything is available and on our store. Our store is like a BlueOS user repository. So if you have an extension, the only thing that you need to do is to provide these 4 lines of code on our repository. You need to describe the name of your extension, where is the website for extension, if it's available. We have also the Docker name for extension and a description for it. With only these 4 lines, our repository is able to identify, generate metadata, and make it available on any BlueOS vehicle. And these are some extensions that we have running. The ultrasonic thickness gauge is really nice because it was Blue Robotics CEO, Rusty, that created. He was checking out how he did our system and he developed himself. We also have sonar view from Cerulean for side scans in the boat, and other DVLs integration. And as an example, OpenVS Code and Node-RED for development, making the software accessible for anyone that wants to do their own development. But there is a particular extension that I want to talk about today. That's something that we're working for 3 years still. And just to talk more about it, just details. We have a long-term relationship with key ground control. By default, Blue Robotics use key ground control since 2015. We developed a couple of prototypes and alternatives since 2019. And we did investigations with frameworks, technology, and soft architectures. We created AMI ground station in Kirogi. And Kirogi is still available by the KDE organization. You can take a look on the KDE organization for Kirogi source code. It was developed on Qt and QML, but the soft architecture was generated from the ground up. I have a relationship with KGC since 2013. I do contributions for close to 7 years in KGC, and I'm currently the KGC maintainer for the stable release. And the entire development team has around probably 30 years of experience in key ground control if you put all the experience that we have together. And based on that, we learned some stuff about ground control stations. Some developers are hard to find. So for Qt C++ developers, they are not easy to find. And besides that, having also experience with Mavlink and drones or cyber-physical systems is really complex. The developers required to collaborate with key ground control are just hard to find, and that's a huge problem for companies that want to do their own custom configuration of KGC. And we know that web frameworks are really well mature. We did experiments with BlueOS, and BlueOS as a proof of concept for that works pretty well. And we also know that stability is key, but like if SpaceX can do front-end development and critical applications using web frameworks, I think we can also can. And there is no one interface to rule that out. There are ground control stations to work with multiple vehicles. If it's aerial, if it's like a surface vehicle, a ground vehicle, or a submarine, you can't design a single interface that will work with everything. So our idea is to allow the user to create his own interface. And we want to share this software with you right now. And this is Cockpit. Cockpit is entirely is a ground control station that you can modify the entire interface and just reorganize it. You can add widgets, modify widgets, resize, change styles, change colors. You can also have different views and different layers of visualization of your vehicle. And the idea is that you can add mini widgets and widgets in general anywhere. It also supports profiles, that you can export a profile to your friend, so you can share the same profile for interface with your friend, and also can export the joystick configurations and much more. The entire interface was designed based on our experience on ROVs and also with flying robots, and we also trying to make it as modern as possible. We try to not be using the old widgets. Widgets are already exist in other softwares, but we still have it because some people just want them. And Cockpit, since it's web-based, it can run in any device. In this case, it's running an e-ink that is following an electric boat. It can also run in a cell phone with a joystick connected via Bluetooth. We also provide standalone applications with Electron for Windows, Linux, and Mac. We also provide Flatpak for Steam Deck, and you can also access the website directly from Cockpit, making it available in any device. I have not a photo with like this Game Boy Advanced emulator, but also runs in the Game Boy Advanced emulator as well. And it's very customizable. By default, this is the interface that you have, but you can remove everything, create like just a layer of widgets with minimal visualization. You can also add a map, change the widgets for something that you already know, and also just have a full map for it. Our idea is that the user can modify the entire interface because each user has a different like style, a different use case, and someone that is like grabbing IOV right now is not the same person that is working with submarines for the last 30 or 40 years. So someone just wants the interface that he used since forever, and someone else just wants an interface that was designing games or something that is like pretty new or like just minimal. And the idea is to allow everybody to have their own experience as possible. And also one more thing, we also support your own widgets. If you're going to create your own widget to have sonar data, 3D viewer of the vehicle, anything truly, you can just create an add-unit. The minimal example is 10 lines of code. So with only 10 lines of code, you can have your own widget on the cockpit. And we also support, in the future, in the coming months, the cockpit API via widgets. With that, your one widget can have access to the data of the vehicle, like API, and it can also arm, disarm, control the motors, receive joystick inputs via the cockpit API that we plan to have. Internally, we have it, so if you create your own widget and put in cockpit right now, it will work. But for a dynamic X widget that will be loaded off-site cockpit, it's still not supported, but our plan in the coming months is support. Right now, it's ready to go for submarines. For boats, it's missing mission planning. Mission planning is something that we still not have. And for other vehicles, it should just work because it's Mavlink based. The only problem is that different from like aerial vehicle, a submarine starts with the joystick in the middle. So if you turn your quadcopter with the joystick in the middle, is something that can be dangerous. So if you're a developer, you want to have integration with quadcopters or airplanes, pull requests are more than welcome. And also one more thing, it's also open source. The idea is to make the source code available before the end of the year. Probably in the next month, we are going to have it open. We are just working the soft architecture to start having people to collaborate with it. And after that, it should be mostly done. And BlueOS is just a platform to be built on. We hope that others may adopt BlueOS. It was designed for that. And we also have a pretty good starting point for it. BlueOS is being used for a long time. It is provided to be core, it just works. Has an extension system ready for people to start adding their own functionalities. And entire source code is open source. As a companion system software that supports extensions, that's something that I believe that doesn't exist. We also have more than 4,000 vehicles running BlueOS right now. And the last 30 days, we have around 300 vehicles that are updated already for 1.1.1 release. So as you can see, every 30 days, we have around 100, 300, one day we have 10 vehicles online. And the idea is to just support quadcopters and fixed-wing airplanes in the future with PX4 integration. We have initial PX4 integration on the master branch of BlueOS, and we plan to finalize it and also add support on our navigator flight controller to PX4 if everything goes fine. And for any questions, if you want to have more information about BlueOS, you can take a look on BlueOS Cloud. That's the web page. You can see all the information about the user interface. You can see how many vehicles we have running the latest version. You can see the products that support BlueOS and more. And we'll be more than happy to add your vehicle in our platform on the BlueOS website if it has. And that's mostly it. Thank you. Any questions?
What's the migration path from Ontario OS?
A what?
Migration path. I've got Ontario OS on the go right now. How do I put BlueOS on Ontario now?
That's a good question. Right now on BlueOS, you have the install script. It's just a single line of code. In theory, you should just grab this BlueOS script and run if you have access to the Linux computer that's running. I don't know if it runs Linux. So you can just run on there. And if there is no support in the install script, you can just add it. The install script was created in an architectural way that has support to any hardware that is listed. So if your hardware, for a specific reason, we do not support directly, you can just add your own bash script for your own hardware. You are going to support it. The script was totally created for it. But if you want just to take a look out of the box, you can just access the terminal. If Docker is available, if you can install Docker on it, and just do Docker run BlueOS with the correct binds, and it should just work as well. So if you want to create your own installation script, you can modify BlueOS for that. And if you want to run BlueOS that exists currently, you can just run Docker run with the correct binds. Besides that, no, that's mostly it for BlueOS. There's nothing more.
Just wondering, what would be required to support surface sailing?
Oh, that depends more on the flight controller than the BlueOS. But we do, in cockpit, we do have plans to have weather integration and also like more advanced maps to provide information about wind, weather, and others related to surface vessels. More questions? Okay, that's it. Thank you very much.